So, you've probably noticed this new wave of AI assistants, right? They don't just spit out an answer anymore. Nope. They claim to think first, showing you this whole chain of thought process. It really feels like we're peeking inside an AI's brain. But what if it's all just a very, very convincing magic trick?
Okay, let's get right into it, because this is the billion-dollar question we are tackling today. When an AI shows you its thoughts, is it actually reasoning its way through a problem, or has it just gotten incredibly good at pretending to think? All right, so let's meet the new kids on the block. Researchers have a name for them: large reasoning models, or LRMs for short. We're talking about the latest models from places like OpenAI, Anthropic, you know the names. And their big feature is generating this whole thought process before they give you the final answer. Now this is where it gets really interesting. A standard language model, that's on the left, you give it a prompt, and boom, it gives you an answer. Simple. But an LRM, on the right, adds this super important step in the middle. It generates a trace of its thoughts. It explores ideas, it backtracks, it course corrects, and then it gives you the answer. The whole idea is that this should make it way better at reasoning, but does it actually work? To figure that out, you need a really good test. And here's the problem. You can't just throw a bunch of math problems at it. Why not? Because of something called data contamination. Think of it like a student who got a copy of last year's exam. They might ace the test, but it's just because they memorized the answers, not because they actually understand the material. So to get around that, researchers came up with this brilliant, contamination-free testing ground. They used algorithmic puzzles. This is super clever because 1, you can make the puzzles as easy or as hard as you want. 2, these specific puzzles aren't all over the internet for the AI to have memorized. And 3, they force the model to reason from the ground up, using only the rules you give it. Best of all, a computer can check every single step to see if it's correct. No cheating allowed.
And we're talking about the classics here. You know, things like the Tower of Hanoi, where you've got to move those discs between pegs without breaking the rules, or river crossing puzzles, where you need to get a group of people across a river in a tiny boat. These are pure, raw tests of logic and planning.
All right, so they ran the tests. Let's get to the good stuff, the results. Because what this whole investigation uncovered was this absolutely fascinating pattern. As they cranked up the difficulty of the puzzles, the AI's performance didn't just go down smoothly. Instead, 3 totally distinct zones or regimes of performance started to appear. First up, the easy stuff, low complexity puzzles. You'd think this would be a slam dunk for the thinking models, right? I mean, they should just cruise through these. But what they found was the complete opposite of what you'd expect. And boom, here's our first big surprise. For the simple tasks, the regular, non-thinking models were actually better. They were more accurate and more efficient. These so-called thinking models, well, they tended to overthink things. They'd find the right answer, but then keep exploring bad ideas, wasting time, and sometimes even messing up the final result.
Okay. So what happens when we dial up the difficulty a little bit? Welcome to Regime 2, medium complexity.
Now this is the sweet spot. Right in this middle range of difficulty, that thinking process really starts to pay off. The LRMs pull way ahead of the standard models. This is where their ability to lay out a plan and explore different steps gives them a huge advantage. So far, so good.
But what happens when the puzzles get really, truly hard? Like when the number of steps you need to solve it is just massive. This brings us to the most revealing, most important part of the whole experiment, the third regime. And there it is. Once the complexity hits a certain point, their performance doesn't just dip, it falls off a cliff. It completely collapses. For both types of models, the thinkers and the non-thinkers, accuracy just plummets. They hit a wall, and they hit it hard.
This point of collapse, this is the most critical clue in this entire mystery. What is actually going on inside the model's brain when it's faced with a problem that is just too much for it to handle?
So here's the bottom line. Once you cross a certain line, a specific threshold for each model, the accuracy on these puzzles drops to absolute 0. Let that sink in. Not 10%, not 5%, 0. A complete and total failure.
But here it is, the single most shocking, most counterintuitive finding in the entire study. You would think, logically, that when a problem gets harder, a reasoning model would try to think more, right? It would spend more time, use more steps, put in more effort. But the researchers found the exact opposite. As the puzzles got harder and approached that breaking point, the models actually started to think less.
And that's the real kicker here. It's not that they're trying their absolute best and just run out of brain power. No, The researchers gave them plenty of room to think, a huge token budget. But when the problem gets too complex, it seems like the reasoning engine just throws in the towel. They just give up.
And the mystery just gets deeper. The investigation turned up a few final, frankly bizarre clues that really make you question what this reasoning thing even is.
Okay, this one is just wild. For the Tower of Hanoi puzzle, the researchers didn't just ask the model to solve it, they literally gave it the perfect step-by-step algorithm in the prompt. They handed it the answer key, and guess what? Its performance didn't get any better. It still failed at the exact same point. That suggests the problem isn't about finding the right strategy. It's about a fundamental failure to follow that strategy when it gets too long.
And get a load of this crazy inconsistency. On the Tower of Hanoi puzzle, a really complex one, the model could follow a plan for over 100 correct moves before it made a single mistake. Amazing, right? But then, on the much simpler river crossing puzzle, which only needs 11 moves to solve, it failed after just 4 steps. This tells us its reasoning isn't a general skill. It's just really good at some patterns it's seen before and terrible at others.
So what does all this add up to? It all points to what the researchers call the illusion of thinking. These models have learned to generate text that looks exactly like human reasoning. It's an incredibly sophisticated, super useful kind of pattern matching. But when you push it past the patterns it knows, when you give it something truly new and complex, the illusion shatters. And that leaves us with this one giant hanging question. If these incredible world-changing AIs aren't actually reasoning the way we do, then what is it exactly that they're doing inside that black box? And what does that mean for the future of all of this?